everyone, Tipene here from the developer advocacy team at Zendesk. With the ever-increasing popularity of digital-first communication we're seeing in the CX space, messaging has emerged as a leading tool preferred by users to get in touch with customer service teams online. With that, we were super excited to announce a release of Zendesk Messaging in 2020. This introduced a new way for organizations to support their customers through rich conversations that are persistent across platforms with full conversational history. For many, being able to quickly and accurately identify end users is a key component of delivering effective customer service. So in this video, we'll be taking a look at how we can implement end user authentication in the messaging experience. At its core, end user authentication is simply the process of confirming the identity of a customer or user. This is done through a combination of signing secrets and JSON web tokens or JWTs. Let's take a high-level look and overview of the workflow used to achieve this. The first thing you'll need is a signing key, which can be generated by a Zendesk administrator in Admin Center. The signing key is a type of credential which consists of a key ID and a shared secret. Next, a backend service should be implemented which generates a JWT when a request is made from your client-side website or app. Here, we'll digitally sign the JWT with our signing key. Finally, the signed JWT is returned to your app, at which point you will use the Zendesk SDK to verify the identity of the user. If this is your first time a user has authenticated with Zendesk, a new user profile will be created for them in your Zendesk instance. If the user has authenticated in the past, the new conversation will be merged with their previous interactions, so you'll have the full conversation history available. If you're unfamiliar with any of the terms or concepts we've just gone over, don't worry, we'll be going over them in more detail later in the video. In this walkthrough, we'll create a simple client-side login form that we'll use to capture our users' details. Next, we'll implement a backend service that generates a signed JSON web token to authenticate the end user. Finally, we'll send our signed JWT to the client side, where the Web Widget will pass a JWT to Zendesk to verify the identity of the end user. You may have also seen that we recently announced authentication for messaging using signed email addresses. While we won't be covering that functionality in this video, we will be releasing a deep dive into this new workflow in future, so watch this space. In the meantime, I've added a link to the documentation in the description below if you'd like to give it a try yourself. Okay, with that said, let's go ahead and get started. To start, we'll go ahead and create a folder here named End User Auth and open the folder in our text editor, in my case, VS Code. First thing we'll need to do is create a new index.html file for our login form. This is where the user will input their login credentials, which will be used by our backend service to validate the user and generate the signed JWT. I've gone ahead and created a simple HTML template to use ahead of time. Feel free to pause the video here if you're following along and would like to add the code to your project. Okay, quick rundown of what's happening here. We have a simple form element which contains a couple of inputs which will take the username and password of the user. We also have a login button which will be used to submit the data to our backend server. We also have the Zendesk Web Widget script towards the bottom of our document which is necessary to initialize the Web Widget in the UI. Finally, we have the script element which is calling the index.js file that will contain the JavaScript for our front end. I'm also going to create a style.css file and add a tiny bit of CSS here to make our UI a bit more presentable. And we'll go ahead and add a link to the style sheet in our document header. Again, feel free to pause the video here and copy across the code. Okay, with the CSS added, let's go ahead and create our index.js file. What we need to do is pass the details entered by the user to the backend server so that the credentials can be verified. Then, if the credentials are authenticated as a known user, we should expect a JWT to be returned, which will then pass to the Zendesk Web Widget. To start, we'll create a variable that gets the login button so that we can manipulate what takes place when it's clicked. Next, we'll create an asynchronous function named login, which receives an event parameter. Inside the login function, the first thing we'll do is disable the default behavior of the form button using the prevent default method. Next, we'll need to access the data entered by the user on the front end, so we'll get the input elements and save them to a username and password variable. We'll also add an if statement that checks whether the input fields have data. If not, an alert is fired in the UI to ask the user to enter the required information. Next, we'll go ahead and create the HTTP request that will pass the data to our server and receive the response. Using the fetch method, we'll add a URL to make the request to. We'll add an example URL here for now and come back and update this a bit later. Next, we'll need to add the request options, so let's go ahead and add the method, headers, and body here now. Since we're sending data, the method will be set as post. We'll set the content type, application/JSON for the headers. For the body, we'll be wanting to pass the username and password data to our backend service, so we'll access the username and password values and pass those as a JSON string. We'll also need to use the JWT that is passing the response from our server, so we'll create a response variable to store the value. And now that we have the JWT, we'll want to pass that to the Zendesk Web Widget SDK to verify the identity of the user. We can do that by using the window.ze method together with the login user API. We'll also provide a callback function here where we'll pass a token from the response variable. If you're not familiar with the Web Widget API and its methods, I've left a link to the docs in the description that will get you up to speed. The last steps on our form here will be clearing the username and password values once the data has been submitted, and finally attaching the login function to the login button on the form. Okay, with that covered, let's go ahead and create the backend service that will handle our authentication. As mentioned earlier, what we'll be doing here is creating a backend service that generates a digitally signed JWT based on the credentials of the user and returns the JWT back to the front end we just built. To start, we'll go ahead and create another file called app.js. We'll be using Express here, so let's go ahead and run npm init to initialize our package.json file. We can leave all these fields blank or default for now. Next, we can go ahead and run npm install Express. If you're not familiar with Express, I'll drop a link to the docs, which has a great getting started guide. Now that we have Express installed, we'll bring the module into our project and initialize it as a variable named app. We'll go ahead and start a server and listen on port 3000 for connections. Before we get further in, there are a couple of other packages and middleware that we'll need to include here, so we'll go ahead and install those now. The first is the JWT package, which is obviously a super important component of this project. We'll also need the .env package, as we'll be using environment variables for our signing secrets. Next, we'll bring in the CORS middleware to handle cross-origin requests. You can choose to enable CORS for all routes or only specific routes. In this example, we'll leave it enabled for all routes, but feel free to make changes on your end as needed. Finally, we'll use the built-in express.json middleware to handle our incoming request body. With that done, let's go ahead and set up our route. We'll start by creating an app.post function with /login as the path and our request and response callback parameters. Now, at this stage, we can already start making requests to the endpoint. We can demonstrate this by adding a console.log here to print the request body and spinning up the server with node app.js. We'll head back over to our index.js and update the fetch URL to our localhost port 3000. We'll also comment out the window.ze method for now, so we don't attempt to log in with our test credentials. Now, let's go ahead and open the HTML with live server and submit a request. You should see the username and password values you entered appearing in the terminal. Now there's a bit more for us to do before we're able to appropriately verify the user, so let's go ahead and remove the console log and add our environment variables. We'll create another file named .env and add 3 variables: shared secret, key ID, and origin. The shared secret and key ID are components of the signing key which I mentioned earlier. These can be found in Admin Center and are required for the authentication workflow to function correctly. The origin should be the domain name we expect the request to originate from. In my case, I'll be using a local host. We'll be using the environment variables in our app.post function, so we'll save those to variables here. Okay, with our environment variables covered, let's move on to the actual authentication workflow. First, we'll need to get the username and password, which is passed from the front end in our request body. We'll use a bit of destructuring to do that here. Next, at this stage, you'd normally want to make a request to your own database to verify the user details against your own records. While that step is an important part of the process, it's out of the scope of this video, so feel free to add your own database verification to this code if you like. For now, we're going to hardcode a variable isAuthenticated with a value of true. We'll also add a quick conditional check here, which will return a 401 unauthorized error if the user is not authenticated. Okay, next up is our headers and payload, which will be used to generate the JWT. We'll create a headers object which will contain an alg property, a type property, and a KID property. The alg value will be the signing algorithm being used, which in this case should be HS256. The type value specifies the token type, which we'll set to JWT. The KID value should be the key ID, which we added to our .env file, so we'll use that here. Next up, we have our payload of data for the JWT. The first value we'll add here is the name. This is an optional field that should contain the full name of the user to be displayed in Agent Workspace. For the purposes of this demonstration, we'll use the username value as we're not pulling any additional details from an external database. Next, we'll add an email address for the user. Again, this is an optional field, but we recommend you include the email where possible. We'll go ahead and add an example email address here for our user. Next up is the external ID. This is a required field that is assigned to the user being signed in. It must be unique to the specific user, so something like username, GUID, or existing ID for your own database would work well here. In this case, we'll assign the username as the external ID for our user. Next up, we have the expiry value, which indicates when the JWT will expire. It's best to set a relatively short expiration time to mitigate risk if an end user's JWT is compromised, so we'll create a variable that generates a numeric date expiration value of 5 minutes from the time the function is called. Last but not least, we have the scope value, which defines the access level of the user. In our case, we'll set the scope as user. And that's it. There's a bunch more that can be said about each of these properties, so if you'd like to learn more, I've put a link to the docs in the description below. Okay, now that we've defined our headers and payload, we can go ahead and generate the JWT. We'll create a variable named token that calls the JWT.sign method. This method takes in the payload we just created, along with the shared secret we stored in our environment variables earlier. We'll also pass the header options we created a minute ago. And that's about all there is to it. When our login endpoint is accessed, the JWT.sign method will generate a JWT and save that to the token variable. The last step in the backend workflow is to provide the token to the front end for verification in Zendesk. We'll add a bit of root protection here by comparing the request header's origin value to the expected origin we declared in the .env file. If it's a match, we'll send the token in the response to the front end. If there isn't a match, we'll return a 403 error with an appropriate error message. Okay, next up we can test that it's all working as expected. First, make sure your node server is up and running in the terminal. Next, we'll head back over to our index.js file, and we can go ahead and console log the response.token to confirm that the JWT is being sent to the front end successfully. Now, we can open our HTML again using live server, refresh the page, and submit a test login. If everything went well, you should see the JWT logged on the console below. Okay, let's go ahead and remove the console log and uncomment the Web Widget method. Now, before we can test this out, here's a quick overview of what happens when a user authenticates. Say you have a new user who has never authenticated before. When they sign in for the first time, a new user profile will be created for them in Zendesk that has the external ID we provided in the JWT payload. If the user happens to sign in for the first time mid-conversation, the new user profile will still be created, and the anonymous ticket they had previously will be associated with the new profile. Now, say you have a returning user who has previously authenticated. Once they've signed in, their new conversation will be merged with their previous authenticated conversation to ensure context and continuity. So, with that covered, let's go test this out. First, we'll go to our front-end form, and without authenticating, we'll start a new conversation. You'll notice here that the bot asks for my name and email address by default, as it doesn't know who we are yet. Now, if we pop over to our Zendesk instance, we can take the conversation, and as expected, there's nothing to identify us as an authenticated user. So, let's pop back over to our front-end form and submit some details for authentication. We'll enter a name and password. For the purposes of this example, these can be anything you like. Hit submit, and now if we head back to our conversation in Zendesk, you'll see that the display name has been updated to the username provided in the form. You'll also see a green tick has appeared next to our name, indicating that the profile is authenticated. Okay, now let's solve this ticket and try signing in again, this time from an incognito window. Make sure you're using the same username and password details as before, and click Login. Now, if we open the chat widget again, you'll see the previous conversation we had a minute ago. If we send a message and head over and grab the conversation in Zendesk, you'll find the message has successfully been associated with our previous conversation history. And that wraps up this walkthrough of the basics of end-user authentication in Zendesk messaging. If you'd like to see a more advanced implementation of a JWT server that interacts with a live database, we also have an example over on Glitch that'll do just that. Check the description below for a link to the app. As mentioned earlier, we'll be doing a deep dive into the new email authentication capabilities in a future video, so keep an eye out for that. And as always, if there's anything you'd like to see covered in future videos, please leave a comment below. Thanks so much for watching, and see you in the next one.